Alright, and we're just going to finish up here and we're going to talk about curve fitting. You know, like not all data that we have is linear. There's a bunch of different equations or curves that we could use to kind of describe the data that we get for statistics. So let's just talk about each of these really quickly. Exponential regression, if I typed in exponential regression right here, it would, the first line would come up with this equation right there. Exponential equations are of the form a times some number times another number that's raised to a different power. And what I saw a lot of kids doing was, say this number was a 2 and that number was a 10, they tried to say 20 raised to some power, and it's not that. Only this b is raised to that power, and the a is kind of like the coefficient out front. And an exponential equation, exponential regression, would look something like this. This is typically what exponential decay would look like if something was declining, or exponential growth would look something like this. So if you have a graph that might look like it's decaying or if it's growing like that, that would be exponential regression. On the test, you will be given a question, and it just has a scatter plot, and the points are, you know, going in a pattern, and all you have to do is say, is this exponential regression, is this linear, is this cubic, and all you have to do is pick the right one, okay? So that's exponential. You might want to draw these just so you have a quick sketch. Logarithmic regression, this is the form of the equation that you would see, and then I think that the equation would only tell you what the base was. And then logarithmic regression equations would look something like this, because they are the inverse of exponential equations. So it would look like that. Alrighty, that's what a log graph looked like. And you could just jot that down. And you already know these. You know what an exponential equation looks like. You know what a log equation looks like. It's just finding the patterns. Power regression. Power regression is kind of, I don't want to say confusing, but there's a bunch of different equations that have powers, like 3x squared, or 2x cubed, or 3x to the 1/2. So there's a bunch of different power equations that you could see, like x squared would look like this. X to the 3rd power would look like this. X raised to a 1/2 power would look like this. There's just a lot of different things. That's why I don't really like power, because it kind of just like is all encompassing, and you're not really going to see very many of that. But if you did have to, if a question said, you know, find the linear regression equation, or find, I'm sorry, the power regression equation, all you have to do is find the power option, which is right there, A, and then it gives you the equation for you. Quadratic regression, this would be the form of the equation that you would get, and a quadratic equation is just a parabola that looks like this. You know, it might be moved somewhere else, but that's what a parabola or a quadratic equation looks like, and you know that because it has an x squared right there. And then cubic regression, you could always just, you know, type in a random cubic equation into your calculator to figure out what it looks like, but this is what cubic regression looks like. And I think that's the last one. Yeah. So if I were you, I might go back through this video a couple times and just jot down what those looked like if you are confused about any of those. But I don't think it's that bad. Let's see, the growth of a rapidly growing bacteria is shown in the chart below. Fantastic. Alright, so we have that. Make a scatter plot of the data, and then which regression model would best approximate your data. Okay, so we have some values, and then we want to figure out which regression model would fit it best. So we're going to make another scatter plot. So scatter plot is up here with the stat plot. So I'm going to go into stat plot, and we actually already have all of this stuff turned on, but it does say that my X list is in L1 and my Y list is in L2. That's fine, but I have different numbers in there right now, so I'm going to go to stat edit, go to my list, and just clear out those numbers and replace it with the ones in this question. So that's what a lot of the time you do spending on this test is typing things in. So the hours since observation is going to be 0, 1, 2, 3, 4, and 5. And then number of bacteria in the range, 20, 40, 75, 150, 297, and 510. Okay. So just to review, we were in stat plot, and we chose plot number 1, just because you could have a bunch of different ones, and we turned it on, and we chose the scatter plot button, and we said our X values are in list 1, and our Y values are in list 2, and then I went to zoom, and I want to use zoom stat because it's just going to give us the best picture possible for the information that we typed in, and that's option number 9. Hit enter, and there you go. That's our picture. So if this is what our scatter plot looks like, is that an exponential equation? Is that a logarithmic equation? It certainly does not look like a parabola to me, so that's not quadratic. It doesn't look like a cubic equation. To me, that looks like an exponential equation. It looks like it's exponentially growing. So which regression model would best approximate your data? I'm thinking exponential. And if we wanted to actually figure out what it was, you could go stat, calculate, and then let's figure out what the exponential equation actually is that fits it. We can go down here to exponential regression, that's 0, hit enter, and I want to tell it to look in list 1, comma, list 2. I'm going to hit enter, and there you go. And it gives me the whole equation written out, a times b raised to some power x, so and I'm just going to round these values to the nearest tenths. So this is 20.5 times 1.9. Don't forget that it's raised to the x. And then what's our correlation coefficient for this question? 0.999. That is awesome. If you had any doubt if we were right or wrong about exponential, that just told us that we were exactly right, because 0.99 is really, really close to a positive 1, which means it's really, really close to a perfect correlation. That means that all those data points that we have pretty much line up exactly on top of the line of this equation, which is awesome. Write the regression equation for your data, rounding to 3 decimal places. We kind of just did that. What's the correlation coefficient? What does it tell you? We just did that. Using your regression equation, determine how many bacteria to the nearest integer will be present in 15 hours. Okay, so this is kind of like extrapolation. It's using the equation that we figured out to, figure out a missing piece, to figure out what's going to happen in the future. So let's see. In our graph, the hours since observation, those were my x's, and the number of bacteria, that was my y. So in this equation, if I'm going to use my regression equation to determine how many bacteria will be present in 15 hours, 15 is my x. And how many bacteria, that's what I want to find out. That's going to be my y. So I need to plug in a value for x, and I'm going to solve for y. Sometimes it's the opposite. Sometimes I'm plugging in for y and solving for x. But in this case, I'm going to plug in 15 for x. So if my equation is y is equal to, and I'm going to round it to 3 decimal places just because that's what they said up there. My a is 20.512. My b was 1.924. And instead of writing x up here, I want to figure out what's going to happen at hour 15. And now that I have all that information, I can plug it into my calculator and let the calculator do the work for me. 20.512 times 1.924 raised to the 15th power. Hit enter, So y, the number of bacteria I will have at hour 15, is 375,910. And it said round it to the nearest integer, and so that's about, there we go. There we go. That's the number of bacteria, which is pretty gross, but hey. So that's how you would use the equation that you have and plug in a value for x and solve for y. Okay? Not too hard. And then this is your next homework assignment. Let's see, page 527, number 125. You know what? I think that at this point she had you do questions out of the green book instead. Page 3, number 21. Let me just make sure that it is the right thing. Page 3, number 21. Yes, that has to do with correlation coefficient and all this stuff. So you need to use your little green book, go to page 3, number 21, page 29, number 27, page 40, number 38, page 45, number 25, and page 46, number 31. That is your homework number 111. And what I'm going to do, John, I actually have to go right now, but either tonight or tomorrow I will go through the practice test with you, which is homework number 112. That way that you can see how, questions on the test are going to be worded, and we can do those together. And then you will be done with chapter 15. Alrighty, I will talk to you later.